Now let us verify Kirchhoff current law with help of this circuit. So you see here I have connected two LEDs in parallel with the supply voltage Vs. So what is Kirchhoff current law? Kirchhoff current law is nothing but at any junction. So in this circuit, this is the junction. At any junction, the sum of incoming current always equal to sum of outgoing current. You can see here the incoming current to this particular junction is I1 and the outgoing currents are I2 as well as I3, right? So as per Kirchhoff current law, I1 must be equal to the summation of I2 plus I3. Now that we are going to verify practically. Now in order to measure this incoming and outgoing current, I am connecting called ammeter in series. Now this ammeter measures the total current from the supply, and that is termed as I1 current. And this ammeter connected in series with this LED, so this is going to indicate current taken by this particular LED. And then I have connected one more ammeter in series with the second LED, so this will measure the current through this LED, so that is represented as I3. Right, now you can see we also put resistor over here, and you know that whenever we are making circuit with help of LED, we have to keep resistor to limit the current. Now let us try to understand how to get the resistance of a resistor. So the formula for finding out the resistance of a resistor when LEDs are connected in parallel is Vs minus VLED divided by N into ILED, where Vs is the supply voltage and VLED is the forward voltage of the diode. N is number of diodes are connected in parallel. ILED is current taken by the particular diode. So here we are going to choose actually red LED. For red LED, the LED voltage, that is LED forward voltage, always 2 volt, and the current taken by the LED is actually 20 milliampere. Right, and you can see in the circuit we have connected two LEDs in parallel, so N is actually 2. I will choose supply voltage as 5 volt. Right, maybe we take it as a 6 volt, better. Okay, now I substitute. Now let us substitute all this data in this formula. Now R equal to 6 is supply voltage, minus 2 is LED forward voltage, divided by 2 is number of LEDs connected in parallel, into the current taken by the LED, which is 0.02 ampere. So if you solve this, we will get resistance as 100 ohm. So we have to keep here 100 ohm resistor. And you know that next important thing, we also need to decide what is the power rating of this particular resistor. For that, the formula is I squared into R. So we know already the current taken by the LED is 0.02 ampere, and then the resistance which we already calculated as 100 ohm. So I am substituting both here, and we are getting the power rating of resistors 0.04 watts, right? Which means we can go with the quarter watt resistor, because quarter watt means it is 0.25, right? So we can go with the quarter watt resistor. Okay, so we have to choose here as 100 ohm with a quarter watt resistor. Right, now let's see the procedure, how to do this experiment. So here I have posted the observation table. So as I said, you need to choose some supply voltage. So in our case we already taken 6 volt, so I can take the supply voltage as 6 now. Now for this 6 volt, you try to note down the reading shown by these 3 ammeters. That is ammeter 1, which is I1, ammeter 2, which is I2, and ammeter 3, which is I3. And you note down this I1, I2, I3 in this table. I1, I2, I3 in this table. Then finally we verify whether you are getting I1 equal to the summation of I2 plus I3. So if it is so, then we can claim Kirchhoff current law is verified. Let's see how to make a KCL circuit in this breadboard. So this is actually red LED. You can see it having 2 terminals, right?
Long leg.
You can see there are 2 terminals. The long leg is actually anode terminal. So as I said that it having two leg, so long leg always anode and short leg always cathode. Okay, now let's see how to connect first two LEDs in parallel. We already seen how to connect two resistors in parallel, right? The same way we can connect these two in parallel. So I'll pick first anode, this one anode, and then I am putting cathode next. Now I'll try to connect one more LED in parallel with this. So you need to keep anode connected in common point on one side, and the cathode must be connected in other side common point. Now these two LEDs are connected in parallel, right? Now we'll connect a supply to this LED arrangement, and also we need to keep resistors. Okay, so actually we are trying to make this circuit in this board. So now what I did is I connected this two LED in this breadboard. Now I am going to connect resistor. So these two LEDs actually connected with one common point, right? So you see now this resistor connected in series with this common point. If you look at this, this is one common side, this is another common side. I can use any one of this, so I'll go with this side. So this is what the common point, that is common anode point. So I'll connect the one end of the resistor on any one of this common point, then other one I keep it on this side. Okay, right? Now what I do is I'll try to connect the ammeter in series with this resistor. So you see this is what the digital ammeter, it can measure maximum up to 200 milliampere. It having two terminal, plus and minus terminal, and this is actually RPS, regulated power supply, which can give voltage between 0 to 30 volt, DC voltage between 0 to 30. So it having again two terminal, plus and minus. So now as per this circuit, I will connect the plus terminal of RPS to the plus terminal of ammeter first. So when we can connect, this is the plus terminal of ammeter, and this is the plus terminal of RPS. So I'll connect both together first. Okay, so we are connected now, and then ammeter negative terminal must be connected with the first end of the resistor, right? So this is what the ammeter negative terminal, just look at this black color indicates ammeter negative terminal. This must be connected with the resistor, first end. Okay, this is the first end, right? You can see, you can use any one of these four line, because you know that all the ports are connected row wise, right? All are connected column wise, all are connected vertically. So I can keep it over here. We have connected RPS plus to ammeter plus, ammeter negative to the resistor one end, and then this two LED we have connected parallelly, and the parallel side, that is the common anode side, connected with the resistors other end. Okay, actually I put here only one ammeter, so that can measure I1. Then if you want to measure I2, I3, you can replace this meter here and there, so that we can get I2 as well as I3. Okay, now next see, we need to connect the voltmeter. So let us connect the negative end of the RPS with the cathode terminal of these two diodes. So you can see in this board we already connected the cathode terminal on this common point, right? So this is what the negative end of RPS, see black color, negative end of RPS. This I will connect with the cathode common point, right? So this is what the cathode common point, right? So I will put it over here. Okay, that's it. Now the thing is that you switch on this RPS, set water voltage given to your batch, and measure the current I1. Okay, and note down the reading in the table. Then you connect the same ammeter now across, that is in series with the this LED, and measure the I2 current. And again connect this ammeter in series with this second LED and measure the I3 current, and note down all the readings in the table. And then you verify whether you are getting I1 is equal to summation of I2 plus I3.